All right, overall, a good job on quizzes last lesson. Turn your textbooks if you go to page 279. I want to review some things that we talked about yesterday as we began looking at kind of connected to the idea of probability, but this idea of collecting facts or information. And what is any collection of facts or information called? Joel? Data or data, however you pronounce it, long A, short A, I don't know. Data. We had that conversation in computer applications too, when we were talking about databases or databases, depending on how you pronounce it. Anyway, specifically though, if data is numerical, it doesn't have to be, as we said before, right? If we were to say, how many of you are wearing gray shirts today versus how many are wearing blue shirts today? Well, gray is not a number. I've got 1, 2, 3, 4... You're both. Okay, great. Anyway, but if we were looking at how many wearing gray versus how many wearing blue, okay, those aren't necessarily numbers. Those are what we call qualitative statistics. But numerical data in general is called statistics. But we also use that term statistics to refer to the study of data, the branch of mathematics that studies data. So for instance, like geometry, study of figures, algebra, study of properties of or mathematics dealing with letters, and trigonometry, study of triangles. Well, statistics, study of data. There we go, study of data, however you pronounce it. We said that one thing we could do if we knew some numbers is we could just make a list of who and how many. We can make that list and we call that a frequency table, right? Even thinking of the probability problems, right? When it lists out at the beginning, there's 7 brown pairs of shoes or those are pairs of contacts, but 7 brown pairs of contacts and 5 green pairs and 4 blue pairs or whatever it was. And well, we can make a frequency table out of that. And at the bottom of the frequency table, though, we'd want to put class the total, right? At the bottom of the frequency table, we put the total, and then we can see how many out of whatever. We can see some probability there if we wanted it. Frequency tables are great if something's already done, decided, right? But sometimes people want to project into the future, and so they want to know what are people thinking. So they may ask questions. Or maybe they're just curious about, for instance, if Grace Christian School started selling spirit shoes. We're not going to do that, believe me. That'd be the most weirdest thing ever. But we're like, blue and gold spirit shoes. Okay, well, we would need to know shoe sizes, right? And so we try to get an idea, okay, most people are what shoe size, because, we want to make money on this, and we've got a mass order. And so we, I'm sorry, Ben, you're outlier tall. Okay, we're going to talk about those later. But we could ask all of you, what's your shoe size, and kind of get an idea of that. And, well, we would ask questions there. What's a question you ask to gather information, to gather data called? Kirsten? A survey. And with a survey, if we wanted to know what is a typical shoe size for a teenager here at Grace, well, the teenagers at Grace, all of you collectively, would be considered the what of the survey? The whole group is called the population. So the population of the group is everybody. But, if it was a really big school, we wouldn't want to poll everybody because we're too lazy. So we might poll just a random group of people. We would want it to be random, all different ages, both genders. We'd want to mix it up a little bit there as far as that goes. But that group that actually gets surveyed, and their responses are supposed to represent everybody else. They do this, by the way, with presidential approval polls, right? They talk about the president's approval rating, and people are like, I don't know, they never call me and ask me what my approval rating is. But they don't call all 330 million Americans, right? They might call 1,000 different Americans across different states, and some in the city, some who live out in the country, kind of get a mixture of it. And from that they say, okay, this is the approval of the president, or approval of this policy, or whatever. What's the group that's actually surveyed called? Sample. That's the sample. And again, we talked yesterday about a random sample. But the bottom line is this. When it comes down to collecting statistics, collecting data, Jalen, we want to know what's normal. For instance, we do this with your grades all the time, Ben. We take a lot of different quizzes, and you take a few different tests, and then the report card doesn't show all those grades, does it? The report card says, this is how this student did. This is kind of a summary of how they performed. And of course, what you see on your report card, class, is your, what's that word? Average. You see your average on there. Well, there are different ways that you can describe what's normal for a set of data. And we see this here on page 279 under measures of censure. So page 279 in your books, And at the top of the page, I told you to write something next to where it says measures of center. What were you supposed to write? Bryson? What's normal? Good. What's normal? What's typical? And in a sense, the purpose of measures of center is to summarize the data. 3 measures of center that you see written there. That's the last sentence of the first paragraph. Go ahead and highlight this or underline it. Mean, median, mode. They all begin with M's. Mean, median, mode. Let's talk about these. Let's start with the mean, because this is the easy one. This is something that y'all already understand pretty well, because you've been being graded on stuff for a lot of years now. The mean, write this down, is the arithmetic average. You actually see it right there, so just mark it. The mean is the arithmetic average. The arithmetic average, mark that. So how do we average grades? For instance, let's just suppose, let's pick on Corey because he's down in front. Let's suppose Corey takes a math quiz and he gets 100. And the next math quiz he gets a 90. And the next math quiz he gets a 92. And then he gets another 100. And then he's just having a bad day and he makes some careless mistakes and he gets like an 80 or something. And so we want to know, okay, how's he doing so far? What's his average? What do I do to average numbers? Let's see what we remember from elementary school. Corey, you're the victim here. Anyway, let's go for it.
Add up all the numbers.
Yeah, we add them all together, and 472, I think, is what I'm getting there. And then what do we do once we've added them?
Divide it by 5.
Yeah, we divide. Now, why did you say divide by 5?
Because there's 5 quizzes.
All right, there's 5 numbers there, right? So we would add up all the values together, divide by however many there are, and that ends up giving us, what, 94.4, I think, if we divided that out. And we would say that that's it. You already did it?
No, it's 62. I'm at 462.
462?
Yeah.
Oh, there's not a 1 to carry. I carried a 1, there's no 1. Thank you. Sorry, your average just fell. 92.4, I think, is what we're getting there. Thank you, fact checker, Core. All right, so 462. And so we would divide by 5, right? How many already kind of you're familiar with that idea of averaging? Add them up, divide by how many there are. That's all you do for the mean. It's that easy. So as long as you remember that mean means average, you're going to be all right. Now, you still have to be able to add accurately, unlike what I just did. And you have to be able to divide accurately, but it's not super hard. Say this with me, class. Mean means average. Together? Mean means average. Again?
Mean means average.
So look at the example problem there on page 279. They gave you an 82, hopefully these aren't grades, an 82, a 42, a 92, a 75, a 63, and 84. This person had really good days and really bad days, if these are grades. Anyway, so, maybe that's the case. Anyway, we add them all together, and they got 438. We're going to trust that they did that correctly. And then they divided by 6, because there were 6 numbers, and they got 73. Seemed pretty easy? Mm-hmm. Now look at the little word problem there under example 7.5b. Go ahead and read that for us, Michael.
If you wanted to find the average...
No, the little 7.5b, the Boston Red Sox problem.
The Boston Red Sox played 4 home games in a week. Attendance for those games was 36,274 people on Thursday, 34,613 people on Friday, and 35,922 people on Saturday, and 35,327 people on Sunday. Find the average attendance per game for that week.
So what they have to do, class? Add them all together. They got 142,136, and then divide by. Now notice there were only 4 games over that weekend, probably a 4-game series, and divided by 4, and they got 35,534. You hope we don't have big numbers because that's annoying. Now again, does that mean that there were 35,534 people at every single game, class? No. Some of the games were higher, some of the games were lower, but that kind of tells them what's normal. Does that make sense? They can figure out what their average or normal attendance is. And the term for average is? Mean. There we go. All right, turn over to page 282. We'll do some smaller numbers because let's be real, like who wants to do big numbers? I want you to do on page 282 just numbers 1, 2, and 3. Page 282, find the mean of numbers 1, 2, and 3. Add the numbers together and divide by how many there are. They don't want a crazy decimal though. So if it's coming out to a weird decimal, cut it off at only 1 decimal place. This round to the nearest 10th. I'm going to turn off the blizzard for those of you who are dying. I'm noticing a lot of you rewriting them vertically. That's not a bad strategy. Makes it a little bit easier. You can try to add horizontally. That wouldn't be a terrible thing to try. But kind of keeps track of place value if you do it that way.
Yeah, I saw that. I'm trying to fact check something real quick. Yeah, your addition was 1. That's just 129.
But otherwise, good.
Yeah. Addition was 1 off. It's actually only 90. That addition's off. I wonder if you missed a number. You did, you missed the 18. So add in the extra 18 and try it again.
Got it.
Fun part is keeping track of all these numbers, right? So,
There it is.
and remember, we're going to round to 1 decimal place.
Just round it off.
Rather, now you're right, it does come out evenly to that, but we don't necessarily have to take it all the way up. Go ahead. Excellent, excellent.
What's 7 times 5? 35. What's 30 minus 35? 3. Okay, so then 5 goes into 30.
There you go. There you go. I would say most of us are about done. Now, again, the hardest part, honestly, with this, in my opinion, is the addition. Because usually you're dividing by fairly small numbers. That's not too bad. But the addition, being careful, and there's so many numbers to keep track of. Check your work on number 1. We should have added to get 129. How many correctly added to 129? Okay, so what do we get for our answer then on number 1, Kirsten?
16.1.
Good. 16.125 if you took it all the way out, but we'll just cut it off at 16.1. For number 2, when we add, we should have gotten 380. How many added to 380 on number 2? All right, so then what do we get?
76.
76. And then number 3, we should have added up to get exactly 90. How many got 90 when you added on number 3? All right, and then what do we get for the average then, Griffin?
9.
9, because we had 10 of the numbers there. All right, questions on finding the mean. Again, it's admittedly a little bit of annoying math work to do, but it's not hard to understand. It's just hard to be careful. Yes, sir?
Number 3, I got 98.
Yeah, so maybe you actually accidentally added an extra 8 in there somewhere. That's a possibility. Do numbers 4 through 6 now. Let's do numbers 4 through 6, and then we'll move on to something that's a little less math intensive, which for a lazy guy like me is nice. Ooh, I feel like we missed yeah, the addition's pretty far off this time on that one, but the first two look great. Good, excellent. Yes, excellent. Somehow the addition's still off. Yeah. Do it on paper. Do it on a separate piece of paper so you can see a little bit better. Good, good, good. Just a wait. Where is it? Yeah, just a nudge off on the addition, but the other two look great. By the way, you're seeing the importance of showing your work on a problem involving the mean, because it's so easy to have a little addition error, something like that. But if I can see that you added the numbers, try to divide, you get half the credit for knowing what to do. So getting that same answer, huh? Let's take a look. Oh, that's a 155, not a 115. And that's exactly what it was too, because that's the exact amount difference that you were off on your answer. And then sometimes you make copy errors, which is like minus a point. So, right, Michael? So yes, you want to make sure you show your work as you're doing these. Let's go over the answers real quick, because I do want to move on to these other measures of center as well, which do not involve as much math. Okay, so laziness, right? We love math for the sake of avoiding it. Number 4, how can we get out of it? Where's the shortcuts? Number 4, should have added them up to get 379. How many correctly added on number 4 to get 379? Okay, and then when we divide by 6, we should get what for our answer, Elaine?
63.2.
63.166666 is what it would end up being. We don't have to take it out that far. We'll round to 63.2. Great job. Number 5, we add those 5 numbers together to get 82. How many added to get 82 on number 5? Added, did you? Several of you. And what did you get for your mean then? Corey?
16.4.
16.4 is correct. Good. That came out evenly. Number 6, added up, and we should get 1,025. Who added to get 1,025? All right, and then when we divide that by 6, what do we get for our mean, Bryson?
170.8.
Good. Rounds to 170.8. 170.8, 33333, but rounded to 170.8. Questions on those? Any questions on those? Now, there's something I want to point out to you, and let's go back to Corey for just a moment. Let's just suppose, hypothetically, remember he had these different grades on his quizzes. So far, class, he's doing pretty good, isn't he? Well, let's just suppose he was taking a quiz over probability, and he got his ors and his ands mixed up, and his brain told him that, this didn't really happen, but did it?
No.
Okay, I didn't think so. Okay, I couldn't remember exactly what your grade was. I'm like, I really hope I'm not actually picking on it. But let's just suppose he got his ors and ands mixed up, and he multiplied every time it said or, and he added every time it said and so he ended up with a 40 on his quiz. Well, remember, his average a moment ago was like a 92.4, right? One bad quiz. And you know this. How many of you know what the feeling, like you have a bad quiz? Yeah, okay, I've been there too, okay? So I know the feeling of having to try to overcome it later, but we add it all up. Let me see if I can add. We don't carry this time, right, Michael? And so 20 to 30 and 5. So we end up getting 502. And we divide now by a 6, and all of a sudden, look, 6 goes into 50, class 8 times with 2 left over. 6 goes into 22 3 times with 4 left over, so that'd be like a 0.7. Man, that's a big drop. 92.4, solid A minus, but it's not like right on the bubble, to a kind of a middle to low B, all from one quiz. I mean, think about it. This is his average. Well, we have to do that, academically speaking, because everything matters in life. We teach you that. But if we were actually to say, what's a normal quiz grade for Corey? We wouldn't say that 83 is normal. Like I would say he's usually a 90s and A student if these are his grades, right? That's so far abnormal. It's something we call an outlier. Something called an outlier. Write this off to the side of page 282 if you would. Just write the term outlier. Because it lies outside what's normal for him. If we were to look at these grades, there's a 40-point gap between this and the next closest grade. Do you see that? That's a huge gap. Well, look at these data sets. Look at number 1. Is there a number that is really big compared to all the others or really small compared to all the others? I mean, there's a biggest, but class, the biggest is
24.
on number 1?
24.
24 is the biggest, right? But there's a 21 that's only 3 numbers different from that, right? So 24 is not really an outlier because there's something really close to it. What's the smallest number? 9, but there's also a 12 and a 13, which are pretty close. So I would say, number 1, there really aren't any outliers. So what that means, class, is that the mean is a really good indicator of what's normal. The mean in this problem is not a good indicator of what's normal. It may be his average, and he's going to have to work hard to make up for that 40. Just kidding, he didn't get a 40. But he'd have to work hard, but it's his average, it is what it is. But if we're trying to describe normal to someone, we wouldn't want to use the mean if there's an outlier. Look at number 2. Is there a number that's really big or really small?
Yes.
Yeah.
90.
Well, 90 is only 5 bigger than 85. I mean, that's right next to it.
55 small.
55 is 15 numbers different from the next closest. That's a little bit of an outlier. And then 70 is 10 different from 80. So 55 is a little bit of an outlier, I would say. You know what that means? 76, is that really a good indicator of what, like if those are people's grades, is that a good indicator of what the student normally gets? I'd say the student normally gets around an 80 something. But that 55 is an outlier. Look at number 3. Do we see any numbers that are either crazy high or crazy low? No, they all look pretty normal to me. Look at number 4. Any crazy high or crazy low numbers? 43 is 11 points different from the next smallest value. That's kind of a big drop. What about 87? That's 12 points higher than anything else. So I would say there's kind of an outlier on both sides in this case. That actually probably balances out and makes the mean pretty accurate. Number 5 rather. Any outliers? No. What about number 6?
Yes.
Yeah, 114.
The 114 is way smaller than everybody else, right? So again, on number 6, the last one we worked, we said that 170.8 was normal. Well, I don't know about that. I feel like it'd be a little higher than that, but there's an outlier. So that's the limitation of the mean. It's very what we call sensitive to outliers. Does that make sense? It's sensitive to outliers. So if there's a bunch of outliers in a data set, we may not want to describe what's normal with the mean. For instance, let's suppose we have basketball games at Grace Christian School. And let's suppose normal attendance basketball players, how many would you guess are normally in the stands for a basketball game?
Like around 20.
20, 30 people come to the games. There's not as many as there probably should be, but first year getting it going again. Well, that last game of the season, senior night, did anyone notice it felt pretty full over there? It got pretty loud, didn't it? Both schools kind of showed up, so there were a lot more people. So if we were to take average attendance, if we factor that in, it makes our average attendance look pretty good. When really, average attendance probably could have been a little stronger. All right? So what we might want to use is something a little bit different. I want you to get this term, though, if you will, as well. Write this term down, the range. The range. Range shows how spread out data is. Range shows how spread out your data is. And it's very simple. You take the highest number minus the lowest. You take the highest minus the lowest. And that kind of gives you an indicator of the range. If we look at number 1, the biggest number class is 24. The smallest number is 9. What's the range? 24 minus 9? 15. Okay, the average is 16. The range is pretty close to that. It's kind of a spread out data set. Look at the next one. Number 2, what's the highest? 90. What's the lowest? 55. Okay, what's the range? 35. Okay. Look at the next one, number 3. What's the highest?
13.
I'm seeing 13. What's the lowest?
5.
I'm seeing a 5. Okay, so what's the range? 8. All right. Do we get the idea of how to find range? Again, the range just kind of tells you how big of a spread there is from the low end to the high end of the data. If there are lots of outliers, like number 7, there's 2 ways to find it. One way is to actually look through the data set. But you know what would be faster than looking through every value and trying to compare? It might be quicker if we literally just take a moment to write all the numbers in numerical order. So look at number 7, and right there in your book below number 7, let's find the smallest number and write it down, class. 15. Okay, write it down and then cross out your 15 that happens to be right above it. The next smallest number is 18. Write it down and cross out your 18 that's at the end of the data set. The next number? 19. Notice how they're all kind of tight together right now. As we're writing the numbers down, we're getting an idea of a very tight data set. The next number? 20. Okay, cross that out. The next number we write down? 22. Cross that out. Then 25. We're going to cross that out. And then 40. Now, did anyone notice a big jump? Yeah, it's all like, they're all within, notice, the range, if it weren't for the 40 class, what's the range? 10. From 15 to 25 is only a range of 10. All of a sudden now, though, what is the actual range, class? 25. That's a big range all of a sudden with one number. Because the range jumps that big, do you see that 40 is considered an outlier? Also, this number is only 3 away from its end. This is 15 away from its end. That's an outlier. It's got a bigger gap in it than all the other numbers. See that? All right, so I want you to do the same thing now on number 8. There's only 5 numbers to write down. Write down the 5 numbers in numerical order. What's that term called? Ranking. Sorry, did I give you that term yet?
No.
Ranking data. Sorry, write that off to the side margin as well. Ranking data. Put in number order. Ranking the data. So go ahead and rank number 8. And then if you see an outlier, circle it. And this one should be pretty obvious. Class, what's the outlier?
7.
7. Yeah, if it weren't for the 7, circle the 7 and ignore it for a minute. What's the range? 6. 48 to 42, right? 6 would have been the range. But with the 7 in there, class, what's the range?
31.
Careful.
41.
41. Wow, what a jump. All from one value. That's an outlier. Does that make sense? Number 9, same thing. Only 4 numbers. Rank them. And again, the outlier they make painfully obvious for you. Peace be still. And how do we write out our ranked data, Jalen?
32, 121, 125, and 144.
Good. 32, 121, 125, 144. The obvious outlier here, Jalen. 32. Class, what is the range of the data on number 9? What's the range of the data? 112. 112. Again, how do we find range, class? Biggest minus smallest. So our biggest on number 9 was 144. Our smallest was the outlier 32, which gave us an enormous range on number 9. Do you understand what an outlier is? Yeah, you can go sharp on that. Any questions on what an outlier is? All right, so if you put the data in order, class, that's called ranking the data. If we measure the difference from the biggest to the smallest, that's called the range. And if there's a number that it's just so different from all the other ones, that's an outlier. Could you ever have 2 outliers?
No.
Yes.
You could. For instance, if we had expanded Corey's data set a little bit here, and let's suppose we tracked an entire quarter's worth of grades. Usually you take about a dozen quizzes, other than English class. There's just gazillions in English. But if we kept tracking his grades, and he had a 90, and an 87, and a 74, and a 100, and a 86, and a 31, and a 94. Okay. Does everyone see there are now 2 numbers that really don't fit in? I mean, you might look at the 74, but like it's not that far from an 80, and he got an 80 already in the quarter, right? But the 31 and the 40 are together. Both of them are just so different from all the other numbers. So you could actually have a pair of outliers in some cases as well. Questions on that? But here's the point. The outliers mess up the average, or class, the mean. They mess it up, right? Now, it can really help your grade. Like if you're normally, a passing student, but you're kind of on the bubble, man, getting 100 can really be a big boost. Conversely, if you're normally an A student, getting a low F could really hurt the grade, right? Outliers do affect the grade. We wish they didn't happen sometimes. There is a way to find normal that dodges the outlier effect, and it's something called the median. Flip back, if you would, to page 280. The median. By the way, you see some of these terms here on page 280 that we'd written on page 282. The term outlier you see there, a data value that's far above or below. You see the term ranked, list of data ranked if they're put in numerical order. And we have to rank data to find the median. So write that to the side. Must rank first to find median. Must rank first to find median. So let's take these supposed grades of Corey and let's rank them. We got to start with his lowest grade. Corey, we just gave you a whole bunch more grades here. What's the lowest grade Corey got in the quarter, class? 31. And we'll cross it off once we write it down. That we don't accidentally write it twice. The next lowest. 40. And we'll write it down. The next lowest,
74.
the 74. Let's write it down. You don't have to do this at your seats necessarily. Next lowest,
80.
the 80. Okay. Then
86.
86. There it is. All right.
87.
87. There we go. Next lowest.
90.
Let's see. Yep. A 90. Okay. So got a 90. All right. Next lowest.
92.
90.
There's another 90. Ah, look at that. There's two different 90s. Okay, we got to write them both. Next lowest.
92.
A 92. I'm running out of room here. I'm going to have to start writing small. Okay, next lowest.
94.
The 94. Drag the camera over a little bit here. Let's see here. Then,
100.
how many hundreds we got?
3.
3 different hundreds. Okay, so we're going to do 100, 100, 100. All right, so we've ranked the data. We can see it in numerical order. Finding the median, if you see this here, median is called the middle value. See it right there in your notes in the book in bold. Median, and then it says the middle value. We're on page 280. Median, the middle value. But it's only the middle when the data is ranked in numerical order. So what we're going to do, class, is we're going to cross off values from our ranked list. Cross off the first and the last. The new first, the new last. The new first, the new last. For every one you cross off at the beginning, you cross one off at the end. I remember my junior high math teacher says like salt and pepper, right? You never pass just the salt or just the pepper. You always pass them together. Salt and pepper, salt and pepper. So I call it the salt and pepper method, class. Salt, pepper, salt, pepper, salt, pepper. Hey, look! That's what's left in the middle. You know the beauty of this? No math required. Isn't that awesome? No adding, no dividing. And let's be real. Would we not agree, if we look at Corey's lineup of grades, a 90 seems like about normal for him. Sometimes he's higher, sometimes he's lower, but 90 seems like a normal grade for him. Now, it wouldn't be his average, not with these two outliers, but the outliers just get crossed off. Now, his hundreds also get crossed off with them, but the outliers just get crossed off. So the median is the best measure of center if you have something with outliers present. For instance, if we were to talk about the average income in America, well, we got some Elon Musks and some Bill Gates and some Donald Trumps and people like that, right? We got some really rich people in this country. And they're kind of inflating the average income. So I don't know if you've ever paid attention to the news. They never talk about average income. They always say median income. I don't know if you've ever noticed that, but when they're talking about economics on the news, they always say median income. Why? Because it takes care of the really, really rich people, and of course there will be some people who are really, really poor. It just crosses them off and it works its way to the middle value. There's a bunch of outliers if we look at what people make across this country. So we talk about median income. That's what we're looking at there. Look at the example problem on page 280. They have a small little list here of 5 numbers. It wouldn't be that hard to find the average, and there really aren't any outliers. So I mean, the average is probably the better number to get, but we lazy. They want the median. So notice they first of all, class, put them in numerical order. What's that term? Rank. They rank it, class. What do we call putting it in order? Rank. What does rank mean?
Put it
Right.
in.
Put it in order. Okay, they put it in order, and then they didn't actually cross it off, but I would. Salt, pepper, there it is, right in the middle, class. 21. There we go. Easy enough. But, look at letter B. Look at letter B. Under example 7.5. See, here they've got a bunch of different values. Now, notice they've ranked them. Look at the ranking set. 22, 24, 39, 56, 56, 56, 61, 71, 73, 80, 82, 80, or 98. If they salt, pepper, salt, pepper, salt, pepper, salt, pepper, salt, pepper, they can't salt, pepper the last time because there's still 2 values in the middle. Do you see that? A 56 and a 61. If they salt and pepper them, they got no values left. Y'all see that? So what do? Write this off to the side margin. If there are 2 middle values, average them. 2 middle values, average them. But I'd a whole lot rather only add 2 things than add 12 things, wouldn't you? And I'd a whole lot rather divide by 2 than by 12. So the median is easy math, if it's any math at all. And so they took the 56, 61, added them up, divided by 2, and they said that the median was 58.5. All right, questions on how the median works. Again, class, the mean is the average, add and divide. But the median is the middle value. Again, mean, class, average, median, middle value. But what do you have to do to find the middle value?
Salt and pepper.
Well, you salt and pepper, but that's after you put them in numerical order. That's called ranking the data. There we go. Okay, so turn over to page 283. Number 10, I want you to put these things in numerical order. Number 10, there's 7 numbers. List them in numerical order. I recommend crossing them out as you write them down, just so you don't miss something, or forget something, or write something twice. But put them in numerical order. Check your work. Did you get them correctly in numerical order? Now, at your seats, salt and pepper them. Now, whenever you're left within the middle, that's your median. Now, that's a good indicator of what's normal. By the way, what's the range for this data set? It says to find the median and the range. This should be easy math class.
Wow.
12. Because range just means the difference between the biggest and the smallest. You just subtract big and small. Go on to number 11. Rank them. There's only 6 of them. This shouldn't take real long. Number 11, rank them. Then find me the median and the range. Rank them and find the median and the range. Joel, what's your median? 50. Good. Now, there's not a 50 in that set, Joel. What did we run into when we salt and peppered here, Joel? There were how many middle values? 2. What were the 2 numbers in the middle?
49 and 51.
Should have ended up with a 49 and a 51 in the middle. How many also ended up with those 2 middle values? Now, technically, class, you should add and divide by 2. But let's be real, folks. What's right smack dab in between 49 and 51? 50. So, I mean, yes, technically you add, you get 100, you divide by 2 to get 50. But, I mean, when they're this close, if you're just like, yeah, 50's in the middle of that. As long as there's 2 middle values, that's what you do. I like it better when there's only 1. I don't have to do any thinking. All right, do number 12. Oh, by the way, what's the range, Joel?
40. Wait.
The range.
8.
Oh, careful. 6. There we go. 52, the biggest, minus 46, the smallest. Just 6. Very tight data set there. Number 12. Number 12. And for some reason, I thought we had 5 more minutes. All right. We will pick up there tomorrow for homework this evening. What I want you to do, page 284. Page 284. Do the review, 36 to 42. Page 284. Do the review, 36 to 42. On page 285, do the homework 1 to 11. Page 285, do the homework 1 to 11. So on 284, do 36 to 42. And on 285, do 1 through 11. We'll take a look at this tomorrow. Have a wonderful rest of your day, and you are dismissed.